We are looking at problem 1 of the section 2.1 homework. So this problem asks us to find the derivative of the function by the limit process. One of the things you're going to encounter in this chapter 2 is you're going to have derivative problems that ask you to evaluate the derivative, and the directions will give you different requirements for how to evaluate the derivative. Specifically, this one's asking you to evaluate the derivative using the limit process. So I really just want to focus in on that, because when you see that on the test, if you don't evaluate the derivative using that limit process, you will be deducted points. If it doesn't say use the limit process to evaluate the derivative, okay, you don't have to. But just be mindful of, is it saying by the limit process, in which case we need to use that. So when I look at evaluating the derivative, let's go ahead. Actually, I'm going to switch colors and try and color coordinate this. So when I want to look at the derivative, we have f prime of x, that function f prime is equal to the limit as x, and I like to use h. So the textbook in WebAssign, they'll often use delta x, and that's fine. I just don't like to write delta x and x because I'm lazy. And so what I do is I use h. Okay, you can use h, or you can use delta x, or you can bring a y in there if you wanted to. I mean, whatever value you really want. But we're really looking at then the limit as h approaches 0 of x plus h minus f of x all together over h. And you might see it sometimes as x plus h minus x, but again, that's just going to reduce to being over h. So this is our limit definition for derivative. And so to evaluate this function using that, I just kind of fill in the blanks. So one of the things that I know is I'm given h. So I already have that, h equals h. Okay, so I don't need to really write that in there. F of x is another thing that it mentions. We want to plug that in, but we're given f of x. So we have, f of x equals x squared plus x minus 1. Don't have to worry about that too much. And then we have this f of x plus h in our definition, and that part usually requires a little bit more work. So I'm going to go ahead and do this on the side. Let's look at what is f of x plus h. So I'm going to input the quantity x plus h in for x, so that gives me x plus h squared plus x plus h minus 1. And when I consider that, I do need to expand that x plus h. So be mindful of that. If we're expanding x plus h, it's not x squared plus h squared. That's a common algebra mistake. Let's not make that here in calculus. So pause the video if you do make that mistake. And note that this x plus h squared is going to be x squared plus 2xh plus h squared. If you don't have that 2xh, again, common algebra mistake, but pause it. Go back and look at FOILing. Go back and look at recursively distributing, evaluating, squaring a binomial. Look at that in your college algebra textbook, just for reference, because you don't want to make that mistake here. From there, there's nothing else that we can simplify. So we have our f of x plus h, and we have our 3 parts. So I go ahead and we have f prime of x equals the limit as h approaches 0. My stylus isn't liking me right now. And we have it of, I'm going to have a really large line of f of x plus h. So that f of x plus h, we're going to have x squared plus 2xh plus h squared plus x plus h minus 1. And then I'm going to have a minus, notice I'm color coordinating it, that f of x, which is what we're given. So the f of x, we're going to have x squared plus x minus 1. You can see, even though I made my line long, I didn't make it long enough. and then over h. Okay, let's go ahead and simplify. One of the first things I'll do is I'll distribute that negative, and I used parentheses on all my parts so that if I did have something to distribute, I could do that. So I have this negative out front. I'm going to distribute that to each of the terms for my f of x. So then I'm going to have the limit as h goes to 0. We have no coefficient out front of that first polynomial, so I'm just going to drop the parentheses. We have 2xh plus h squared plus x plus h minus 1. And then distributing the negative, this becomes minus x squared minus x plus 1. All together over h. And then we'll want to combine like terms. So this will give me the limit as h goes to 0. Let's go ahead and see what cancels. Hint, it's going to be the things that don't contain h. So the terms that don't contain h, such as x squared minus x squared, those combine to be 0. So we don't have to write that. This plus x and minus x, those combine to be 0. And then this minus 1 and this plus 1 also combine to be 0. So what we're left with after we simplify is we have this 2xh plus h squared plus h all together over h. From here, we can factor or we can split it up into 3 rational expressions, the sum of 3 rational expressions. I'm going to go ahead and factor out that h. So then we have 2x plus h plus 1 all together over h. We can make a quick side note. Hey, h does not equal 0. So we're finding a function that has an equivalent limit. And so this limit as h approaches 0, 2x plus h plus 1. We can now substitute in 0 for h. So we get 2x plus 0 plus 1. Or in other words, f prime of x. Squeeze that down here. F prime of x is equal to 2x plus 1. 2x plus 1. So on your learning assignment, this is going to be that first problem. It's going to say evaluate a derivative using that limit process. It's really in the section 2.1 that you do that. After that, you're going to learn the shortcut rules. You don't have to do this, but you are going to be asked to verify or to evaluate a couple derivatives using that limit process. So just kind of keep that in mind. Pay close attention to what the directions are asking you. And even as myself, someone who knows the later chapters, knows the shortcut rules, I still like to, check what is the derivative using those shortcut rules mentally, and then making sure that my answer matches that. That's perfectly fine to do. All right.